Hey, what's happening, guys? Today we are going to talk about LED basics. This video is like a primer for the complete beginner. So if you're more advanced into electronics, you might want to skip this one. That's perfectly fine. But if you want to learn about LED basics, stick around and we're going to talk about it. And I'm going to take you from not knowing anything about LEDs to being able to use them safely in your electronics projects. They're a lot of fun and they're not hard to use. So the first thing I want to talk about are the sizes. I'm sure there's more sizes than this, but these are the most common. We have 10 millimeter, 5 millimeter, and 3 millimeter. And if we hold them all up next to each other, and I'll hold them up kind of close here, so you guys can get an idea of the size difference. The 3 millimeter and the 5 millimeter are relatively close. The 10 millimeter is considerably larger. But they all behave in exactly the same way. And you need to know 3 specific things to get your LEDs to work. Thing number 1 that you need to know is the polarity. LEDs are polarized devices. That means they have a positive side and a negative side, which are known as the anode and the cathode. They are sometimes abbreviated as A and C, and sometimes in older drawings or older gear, you will see the C sometimes listed as K. But just remember, A is positive, anode positive. Positive, positive, positive. So if we take a look at what the inside of an LED looks like, I'll be able to maybe help you understand it a little bit better. So the inside of the LED consists of 2 parts. This first part is called the post. And there's this wire that exits out of the bottom of the LED. The second part is called the anvil. Oops. You have to be at the same level, Paul. This is the anvil. And you'll notice I didn't draw it very well here, but the wire on the anvil is shorter than the wire on the post. The anvil is your negative side or the cathode side. And the post is your positive side or the anode side. So sitting inside of that little divot in the anvil is what's called the die. And then breaching across from the tip of the post into the anvil is what's called the bond wire. And all of that is encased in your clear plastic little casing. Are you with me so far? So, because this is a diode, LED stands for light emitting diode. A diode is an electrical one-way valve. And one of the ways you can tell that is by its symbol, which is the triangle with a line. This being the positive side, this being the negative side. The anode and the cathode. So when you look at that, and if you look at that and think of that triangle as flow, the current is only going to flow that way. If you try and come this way, there's a wall here. Nothing is going to happen. So you need to hook up your LED with the anode side, the positive side, to the positive part of your power supply, whether it's some sort of bench power supply or a wall wart or a battery or whatever. has to be hooked up this way. If you hook it up backwards, and we're talking about low voltages here used for LEDs, generally say under 12 volts, nothing's going to happen. It's simply going to behave as a diode, and it's going to block it. It's not going to light up, but nothing bad will happen. At higher voltages, you can blow it up. Maybe we'll see that in this video. Stick around. So that's the first thing you need to know, the polarity. How do you hook it up? Second thing that you need to know is what is called the forward voltage. And when you buy your LEDs, you're going to get, generally speaking, some manner of either a chart, like if you have multiple LEDs like this, these are not what I would call very accurate. Or if you get single ones in a bag, they'll have it. But the forward voltage, and we'll talk about that in a minute. Generally, for a red LED, it is going to drop about 1.6 volts minimum. It can be more, but minimum. A yellow LED is going to drop just a little over 2 volts, like 2.1. And an orange LED is going to be right around the same area, 2.0 to 2.1. A blue LED, which were the last to be invented and the most difficult, is going to be about 2.4 volts. Green LED is not much different from the yellow. It's going to be somewhere around 1.9 volts. Then when you get into like an ultraviolet, it's going to be up around 3 volts. And you get the clear white LEDs, the clear white ones, not the ones that have a phosphor coating. They are going to be about 3.5 volts. So that is your forward voltage. And that's an important thing that we're going to need to know when we talk about our third thing, which is the current. So thing number 3 is the current. The current is the electrical push. Diodes by themselves, whether they're signal diodes, power diodes, or light emitting diodes, do not limit current. They will take all the current you can give them, and when you exceed their breaking point, they will simply burn up. Now, most of your consumer LEDs, whether they're 5 millimeter, 10 millimeter, 3 millimeter, are going to be rated at about 20 milliamps. Okay? Doesn't mean you have to run them at 20 milliamps. You can run them at 1 milliamp, and I'm going to show you this. You're not going to notice much of a difference. And you can run them as high as 30 milliamps. You get above that, you're pushing it. But they're going to be rated for 20 milliamps. 1 milliamp, a little on the low side. Good for an indicator, it's not going to blind you. 20 milliamp, like 20 milliamp blue LED is going to blind you if you look at it. I mean, it's not going to permanently blind you. It's going to dazzle you. I find that if we take our little consumer LEDs and run them at about 10 milliamps, not only will they last longer and produce enough light to do what we want, but they're more pleasant to the eye. Of course, that's just me. So now that we have these 3 things to hook up our LEDs, we need to know how we're going to limit the current. That's the last thing. Well, we're going to employ Ohm's law. V equals I over R. So we know our forward voltage, but that's only part of the problem. We also need to know what our supply voltage is. Are we running it from a 9-volt battery? Are we running it from a desktop power supply? What are we running it as? So we're going to use this little formula to figure out how to calculate the LED we need. We're going to say Vs, which is our source voltage, minus VLED, which is our forward voltage, divided by the current will give us our resistance. Basic Ohm's law, right? So let's say we're going to use an LED that requires 10 milliamps and it's powered by a 12-volt battery and its forward voltage is going to be 3.4 volts, okay? So let's fill in the blanks here. We have 12 volts minus 3.4 divided by 0.01, that's 10 milliamps. Do the math. I'll wait for you. Break out a calculator if you have to. But it's going to give us about 860 ohms to get us that nice 10 milliamp current that we're looking for. What if you don't have an 860 ohm resistor? Well, use what's close. This isn't perfection required. This is get close and you'll be okay. So now we know all the things we need to hook up our LED. So let me give you a little diagram and then we'll play with some real LEDs. Okay, so we're going to take the values that we used just a second ago. Our voltage at the source is 12 volts. Our voltage drop, our forward voltage for the LED at 3.4 volts, a 10 milliamp current, and a resistance of 860 ohms. So those are our values. So the first thing we have in our circuit is, could be a battery or anything. So we'll just draw the standard battery symbol. Okay, the long side is a positive, short side is the negative. So there's our positive side, there's our negative side. Now let's draw in our LED, which, remember I showed you the diode symbol. It is a triangle with a wall at the end of it. But to show that it's a diode, you simply put a couple arrows showing light emitting from it. So now we know that it is a diode. And then we also have our resistor. Two different ways to draw a resistor. You can draw it as a box, or you can draw it as a squiggly line. Doesn't matter. You'll see them both. Me personally, I'm a squiggly line guy. You do whatever you like. So the question becomes, where do we put the resistor? Remember I told you the LED is polarized. So if we take this line out here and we make it in red, this is our positive. We must hook the positive part of the battery to the anode of the LED. And then we'll say blue is our negative. That is our cathode. But we can't hook it up like this. If we do this, it is going to blow up. So the one thing that is not polarized, well, there are many things that aren't, but one thing in this circuit that is not polarized is a resistor. Resistors are unpolarized. It doesn't matter which direction you place them, and it also doesn't matter on which side of the diode you place them. So we can take our 860 ohm resistor and place it before the diode, or we can place it after the diode. It doesn't matter, as long as it is in the circuit, because what a resistor is doing is simply controlling the current going through the circuit. So for the purpose of this discussion, we are going to put our resistor on the bottom side of this, which would be in conventional current flow after the diode. All right. So we have the positive side of our battery going to the positive, or the anode, of our diode. And then we have the negative side, or the cathode, going to either side of a resistor. And remember, to have an electric circuit, we must have a complete circle. The electricity must be able to get back there and complete the circuit. Boom. So if we have 12 volts here, and we have 860 ohms here, sometimes you might see a value of a resistor smaller than 1 kilo ohm written with an R. If it says 860R, that's the same as the ohm symbol. So if we have 12 volts here, we have 860 ohms here, and we have a VLED here of 3.4 volts, then by using Ohm's law, V equals I over R, at any point we measure in this circuit, let's say we measure this point right here, we are going to get 10 milliamps. Is it going to be exactly 10 milliamps? Probably not. Why? Manufacturing tolerances in products are not exact, but it's going to be close. Let's say it's going to be between 8 and 12 milliamps, which is going to be just fine. All right, let's take a look at some LEDs. Okay, for our demonstration purposes here today, we're going to use my power supply. And we are going to set its voltage down to 5 volts. And we are going to limit its current to 20 milliamps. All right, I'm gonna put you back in the holder, hang on. All right, I changed it up a little bit to 3 volts and 10 milliamps, just so that we're simulating having the proper resistor in there. But what I want to show you is I have 3 LEDs here. A 10 millimeter, a 5 millimeter, if you still can't see them. I'm trying to get them close enough I can get them in the camera. Okay, hold on here. 10 millimeter, a 5 millimeter, and a 3 millimeter. So we have 3 volts as our source voltage and 10 milliamps. So let's start with the biggest one. Short leg is our cathode, our negative. That's the black coming off my power supply. Long leg positive. Make sure we're separated. We want to short them out. Turn it on. So the LED is lit, which you can obviously see. And you can see from 3 volts, we are at 1.93. All right, so you can calculate their voltage drop from there. 1.92, close enough. So that's our 10 millimeter LED. Let's do a 5 millimeter LED. Now, what's your prediction? Is the voltage drop going to be the same? Or is it going to be more? Or is it going to be less? Here we go. .92, 2.01. We're talking what? 8. We're talking 10 millivolts there. And whoops. Just so you can see, yeah, that is on. 10 millivolts is pretty negligible in this case. And then our 3 millimeter LED. There's our short leg. There's our long leg. And we'll hook them up. 1.83. So it's within 5 millivolts of the 10 millimeter. And within 7 of the 5 millimeter. So as you can see, they all behave pretty much the same because they're the same color and are using the same chemistry. Well, what happens if we hook it up backwards? So long leg, which is our positive, I'm going to hook up backwards. Nothing. You see, it draws no current, it doesn't light, and at these low voltages, it really shouldn't do any damage to the LED. There you go. She's nice and lit up and working just fine. All right, so your next question has to be, well, what happens if we don't limit the voltage? Well, let me show you. So we'll come down here. Wrong button. And we'll set this guy for our maximum current. I said voltage, I meant current. So that's 6 amps. No current limiting whatsoever. What's going to happen when we hook this up now? Going to get a brief flash and that'll be it. Here we go. 1, 2, 3. Oh, Paul, you dum-dum, got to turn it on. 1, 2, 3. There she is. Kind of self-limiting there because we're only at 3 volts. But what happens if the voltage were higher? There's 4 volts. She's still on. Oops. 5 volts and she's dead. So let's try another one. I'll grab another red LED out of the package. And we'll do the same thing. 5 volts is still considered low voltage, by the way. But no current limiting. It's probably going to blow right away, right? 1, 2, 3. There. You got a blip, and that was it. Nothing else. Well, what happens if we do what's not exactly low voltage? Let's say we accidentally hook it up to 32 volts at 6 amps. What is that going to do? Are you ready? 1, 2, 3. We got a little crack out of her. That's about it. Sometimes they might blow up, sometimes they could melt, but really, that's about all you're going to get. So, I hope this video was useful to you in teaching you how to use LEDs in your project safely. If it was, please give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to all the patrons, and big thanks to you guys for watching. That's it. I'm out. Peace.